Hey, last week in your guys' attendance task, I asked you guys a couple of questions and I said I would get to them next chapter. Well, here they are. So I asked you guys a few questions. Asked you guys a scale from 1 to 5. What'd you think of the statistics class before we kind of went on this little online adventure? And then I asked you to rate the class after we went on the online adventure. I also asked kind of like when you think life is going to get back to normal. So you guys entered that date. And here's some of the responses that I got. And we're going to be testing some claims that I have based on this data over the next couple of days or over the next week. So here's on a scale from 1 to 5. Here is your guys' results. And this was afterwards. Definitely some changes. Definitely it has not remained the same. We'll get more to that next week. And then obviously here were some of the dates that you guys had picked. My favorites obviously are April 2100 or January 3000. Yikes. Anyway, I digress. So what I did was I took your guys' information, kind of cleaned it up a little bit. And we're going to look at this information over the next couple of days. So what we're going to do today is we're going to be looking at your guys' before we went on this little online adventure, how you guys rated statistics. And we're going to break that down into women and men into two groups because that's what we've been learning how to do is kind of split information into two independent samples. And then we're going to do the same for the number of days until things get back to normal. So I took your guys' dates that you guys had pressed, and then I pretty much just subtracted it from today, and this is just kind of what we have. Now, clearly for purposes of this problem, I am going to get rid of the two outliers. Thanks, Lizzie and Aiden. But these just numbers are way too big. Don't want to work with those for these problems. So without any further ado, let me talk about what we're going to learn today. So we are going to be learning how to test the difference between means, but this time with small independent samples. The reason why I split groups into men and women is because, again, they're independent of each other. They're not the same group from one sample to the next. They're completely two different groups of people. So that is, again, why we split the way we did. Now, for these problems, and this is, I know, going to scare a couple people, my bad. But here is the main difference between what we were doing before. Yes, we're going to be going back to T's or T-scores because, of course, we are going to be dealing with samples less than 30. The main equation that we're going to be dealing with is this one up here. So you're going to take two sample means, kind of like we were doing last time, subtracted from each other, divided by what is known as the standard deviation of the difference of means. Now, this is going to look different depending on two scenarios, okay? So let me break down these scenarios, but pretty much the problems that you guys are going to be working on will tell you which scenario you are going to be dealing with, and therefore which equation you are going to be using to calculate your overall test statistic. I'll do it an example of both so you guys can get a flavor of them. Now, obviously, these look a lot scarier than they actually are. You'll be letting the calculator do most of the work. But let's talk real quick about what these mean. So population variances. A variance is similar to a standard deviation. A variance is just a measure of how spread out your data is. So if the way your data is spread out is equal when you look at the populations of your samples, so in this case, men's and women's responses to when we're going to get back to normal or what you thought of statistics. If you look at their populations, if you think that, or if we know that the way they're spread out, their populations is spread out in terms of data, if those are equal, we have to use this equation to figure out this bottom part of our overall equation. And as you can see, like last time, everything is noted the same. So standard deviation of the first group, sample size of the first group, standard deviation of the second group, so on and so forth. Now, again, because we are using T-scores again, because the sample sizes are less than 30, when you're dealing with this scenario, you will be finding the degrees of freedom by adding up the two groups to find a total sample. and then subtracting 2 from that, and that's going to be how we're getting the degree of freedom when population and variances are equal. Now, population variances not being equal would be, for instance, if you're looking at your sample's population data and the way that the data is spread out from one group to the next, they aren't the same. So like, for instance, maybe you are looking at 9th graders and 10th graders in the state of Michigan and their thoughts of the TikTok app, right? From 1 to 10. Maybe, for instance, the one group, their data is all really chunked into like pretty much the same. Everyone was answering 5, 5, 5, 5, 5, 5, 5, 5, 5. But the other groups was all over the place, all the way from 0s, all the way up to 10s, all over the place. Their variances or their spreads of their data would be different. So that would be an example of the population variances not being equal. When that's the case, or when the problem just tells you that the population variances are not equal, you'll use this equation, which is, in my mind, way easier, and it is identical to what we were doing before in large samples. It's the exact same bottom of this test statistic equation. The other main difference for this one is the degree of freedom. The way you calculate it is you actually have to look at whichever one's smaller. So either your first group, -1, or your second group, -1, whichever number is smaller, that is your degree of freedom. And that's pretty much all you have to know for that. Beyond that, it's going to be the identical problem to what we were doing before. Just the math part obviously is going to be a little bit different. And obviously when you're looking at the chart, also going to be a little different. So let's get into it. So I am trying to test if there's a difference between men and women when it comes to what they thought of the statistics class before we went online. At a level significance of 0.05, is there enough evidence to support that there is a difference between what men and women thought about the class? Assume that the population variances are equal. So, crap. We're going to have to deal with this one first. So let's go ahead and get started. The first step is to write your null near alternative hypothesis because the claim is that they are different. I'm going to write my null alternative like this, that the mean of the first group, aka in this case, we'll say, when I'm looking at my data, we'll say women are group 1, so we'll call this this is group 1, and then men will be group 2. And it's arbitrary. You could define it however you'd like. In this case, because it's equal to or not equal to, it really doesn't matter which one's group 1 or group 2. But I digress. That is what it's going to be. So pretty much saying that women are not going to equal men when it comes to like the averages. There's going to be a difference. So let's go on to the next part. The next part would be to actually break down your data and getting, like the sample mean, the sample standard deviations, all the stuff that you're going to need for the math part of your problem. Now you could obviously get the tail test going, but let's just get all the math part done first. So what I'm going to do is I'm going to do, your typical equals average to find the mean. So I will select my numbers for the women. I'm going to do equals standard deviation, and I'm going to select that as well. That will be my standard deviation. And then lastly, there are, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that will be my sample size. Let's do the same for the men's group. So average. Let's go ahead and select that. We'll do standard deviation. Again, do .s because we are doing a sample standard deviation. And then there are 1, 2, 3, 4, 5, 6 men in this sample. So and there we go. Let us write, probably a smart idea will be to make a table of that. So voila, there's my table of group 1 and then group 2. You'll notice there's a little bit of typo there. That should be N2. My bad on that one, but yeah, that's sample size for group 2. The next thing I'm going to do is going to do my tail test. This is clearly going to be a two-tail test because of the whole not equals sign for the alternative. Now, finding the t-score for this one. Because we are dealing with the variances being equal, we are going to add the two groups sample sizes up and then subtract 2 from that. So 10 plus 6 is 16 minus 2 is 14. So that's going to be our degree of freedom, and our level of significance will help us look up our t-table. So we got a 2-tail, we got 0.05, and then we're going to go down to the 14th row, which is the 2.145. So we'll write that down. So we got 2.145 and a negative 2.145 like we normally would do. Next part is going to be our math part. So just to give you a heads up on what that might look like. So there's the equation, and then these are all of my numbers plugged into the equation. So obviously we got the sample size of the first group going into the sample size of the first group, standard deviation going into the standard deviation slot, so on and so forth. Let's just make sure I did all this. Looks like I typed it in all good. And then, yeah, you're just going to calculate this. Now, the way I'm going to calculate this is I'm going to get this first square root all calculated. Then I'm going to get the second square root all calculated, and then I'll multiply those two values together. So if you want, you can pause the video. This is generally where obviously people are going to make mistakes. So you can pause it, check to see on a calculator if what you're getting, and see if you get the same as me. All right, for those of you guys who paused it, here goes. So I got 0.887, and I rounded a little bit for the first square root. This is after I square rooted it, of course. And then I got 0.516 for the second square root after I square rooted it. And then multiplying those two decimals together, I'm getting approximately 0.46. So this is going to be the standard deviation of the difference of the means. Now, this isn't my final test statistic. This isn't it. So what you're going to do next is you're going to go back to the actual test statistic equation, which is this. At 0.46 is really just the bottom part. So all that work is just for that denominator section. And then you're going to take your two sample means. So the sample mean of group 1 minus the average of group 2, in this case the women minus the men. And then you're going to divide it by what you got from, again, all that previous work. And if you would like, you can go ahead and try to calculate that. I'll pause. Okay, and then let's go ahead and calculate it. So I'm getting negative 2.83, and as before, we're going to think of this as a number line. Negative 2.83, it puts us to the left of negative 2.145, so that means we are in the shaded section, which means that when we're in shaded section, HO is false and HA is true. Therefore, that would make my claim true. So that's saying, not sure why, but it seems that men and women think the class, however they thought of the class, there's a difference between the two groups. So interesting findings. I'll have to ponder what that really means later. But anyway, let's go on to the next problem. So I think that men, after kind of just taking a quick glance and just knowing what I know about just life, I think men will think that we're going to get back to normal before women do. At a level of significance of 0.01, is there enough evidence to support this claim? This time we're going to assume that the population variances are not equal. And the reason why is, especially even looking at the sample data, the way that this data is spread is going to be all over the place for men and women when we look at if we were to have the entire population do the same like guessing game when the world gets back to normal. So because of that, I'm just going to assume that the population variances are not equal. So let's start with the null and the alternative. The alternative this time is going to be men think that we are going to get back to normal before women. So therefore the average for men in terms of the number of days before we get back to normal is going to be less than the number of days women think we're going to get back to normal. Let me again just kind of show you this in this chart. So in this case, I've kind of swapped. I think I want my group 1 to be men just because it'll make it easier to write the null and the alternative. Here's group 2. So getting back to this is going to be the null and the alternative for this. Let's go ahead and calculate the mean and standard deviations for all that. And it looks like we already have that all done for us. So that's awesome. We're going to go ahead now and let's just put that in a table. So I have The sample mean is 58.2, standard deviation is 23.3. This is, again, for the men. So on average, the men think it's going to be 58 days before we get back to normal. Women, on the other hand, 196 days. Now, on face value, you might think that the statistics is, well, it's game over. It's clearly right. Men definitely think we're going to get back to normal before women do, but not so fast. If you'll notice that the standard deviations are different, and because things are a little bit different, that could be enough to kind of sway the results of this hypothesis test. So more on that momentarily. But here we go. So it's going to be a left tail test. Because the variances are not equal, we're going to take the smaller of the two groups, subtract 1, and that's going to be our degree of freedom. So in this case, the smaller of the two groups is going to be 5. Minus 1 is 4, and that is going to be our degree of freedom, and we're just going to link that up with the 0.01. So I'm going to go here, 0.01 for a one-tail test, and we're going to go to the fourth spot, which is 3.747. So there we go, and I'm going to make that a -1 because, again, we're doing a left-tail test. On to the math part. So we're going to use this formula for the standard deviation of the difference of the means because, again, population variances are not equal. Standard deviations, we're going to plug back into the correct spots. And so standard deviation of the first group there, standard deviation of the second group there, sample size of the first group, boink. And then again, you'll notice I made a stupid typo there. This should be a 2, but the sample size of the second group goes there. I'm going to go ahead and calculate that. You can go ahead and give it a shot. Pause the video if you'd like. All right, here's what I got. When I did everything and then square rooted, I got 53.1. So let's finish out this problem. So the two means subtracted divided by that standard deviation of the difference of the means is going to give me my final test statistic. And when I do that, drum roll, I get -2.6. So clearly there's a difference, but is there enough difference to, again, support this claim that I have? So -2.6 puts us actually to the right of -3.747. So that actually would mean that the HO is going to be true and HA is going to be false. Therefore, my claim is actually false. At this level of significance, it's probably the only thing that would pass would be that they're the same. Now, you might say, well, that's ridiculous. The average for women is clearly bigger than men, so why wouldn't this work? Well, it really has a lot to do with two things. Sample sizes could play a part, and also standard deviations, which actually play a huge part in really determining this. So if the standard deviations were similar, then by all means, I think that, yes, this claim would have been true. But because the data, at least for the women, was a little bit more spread out than the men, that there would have had to be a much bigger gap between the means to actually prove this claim to be true. So anyway, I hope you found that interesting. I did, at least. And we will be obviously working on an assignment similar to this today. So if you have any additional questions, you can always drop by office hours 1 to 2 every day, Monday through Thursday. If not, you have a wonderful day. I'll talk to you later. Bye.